Hi everyone, my name is Monica and I'm a 7th grade science teacher in Chicago, Illinois. Shout out to you for taking the time right now and making sure that you are ready to go for your students. The big question that the plate motion unit drives towards is, why are fossils of species that once lived together found in different locations on Earth now? But before we begin, make sure that you have the following things. 1, you have read and annotated the unit overview, unit at a glance, and standards. 2, you have read and annotated the science background knowledge. And 3, you have in front of you the unit internalization guide and have a pencil or pen in handy. So, why does plate motion even matter? Well, plate motion helps us understand how the surface of Earth has changed over millions of years, and most importantly, is still changing. It helps us develop a better understanding why these changes are occurring. Let's go ahead and dive right into those chapter overviews. In chapter 1, students will answer the question, what is the land like where Mesosaurus fossils are found? In chapter 1, they begin by taking a pre-unit assessment. They then watch a quick video where they meet Dr. Wilson, and they learn that, like Dr. Wilson, they also will be using fossils to guide their investigation of what Earth was like in the past. They are then introduced to their unit phenomena, which is that in the unit, they will be using their understanding of geology to explain what happened to the rock that the Mesosaurus fossils were found in, and why the fossilized remains of these reptiles that once lived together are now found so far away from each other. Students are then broken up into small groups where they study different cross-sections of areas on Earth to determine what the land is like. They ultimately come to the understanding that Earth's outer layer is made up of hard, solid rock, no matter where they look on Earth. They then watch a quick video where they are shown a 3-dimensional computer model of the surface of Earth if all of the water was taken away. They then use this sim to explore representations of Earth's outer layer and compare them to what they saw in the video. Students then complete a hands-on activity where they learn that there is a connection between earthquakes and plate boundaries. Here's where they learn that geologists look for patterns in landforms and in geologic events in order to better understand Earth. They also come to the conclusion that Earth's outer layer is divided into sections called plates. Now that they've made this connection between plate motion and earthquakes, they have a new question that they must investigate. What happens to Earth's plates during an earthquake? Is it claim 1, plates move, which can cause earthquakes? Or is it claim 2, that earthquakes cause plate motion? They investigate this question by completing an activity on the simulation. They learn that plates of Earth's outer layer move, and they know that because earthquakes provide this evidence for plate motion. They come to the conclusion that the reason we have earthquakes is because of plate motion. This leads us to our progress build 1. Earth's entire outer layer below the water and the soil that we see is made up of solid rock that is divided into plates. Earth's plates can move. Go ahead and pause the video now. Take a look at the chapter 1 focus task. Try to complete it on your own. Here is an exemplar for the chapter 1 focus task. Go ahead and pause the video now. Compare the exemplar to your response. All right, let's dive right into chapter 2. In chapter 2, students answer the question, how did the South American plate and the African plate move? Students use the simulation to determine how the mantle is different from the plates that make up Earth's outer layer. Then they complete a very fun hands-on activity with silly putty and a plastic cube to explore the characteristics of soft solids and hard solids. They learn that rocks can either be hard and soft solids, and then they come to a conclusion that Earth's plates move on top of a soft, solid layer of rock called the mantle. They also learn that if the mantle had been a hard solid, Earth's plates would not be able to move. Students then read an article called Listening to Earth. The purpose of this article is for students to learn about different ways that the mantle interacts with plates at convergent and at divergent plate boundaries. They then work together to create a physical model of moving plates using two towels and chairs. Students then create a cross-section models of convergent and divergent plate boundaries. They add arrows to indicate the directions of the plate motion. They gather some more evidence from the sim to revise their models. And they learned that at divergent plate boundaries, rock rises from the mantle and hardens, adding new solid rock to the edges of both plates. At convergent plate boundaries, one plate moves underneath the other plate and sinks into the mantle. Students use earthquakes and landform evidence to determine that plate boundary between the South American plate and the African plate is actually a divergent plate boundary. They then model their understanding of how the South American plate and the African plate moved and how the mantle interacts with these plates by drawing that plus arrow to show that the mantle actually rises as these two plates are moving away from each other, and the mantle adds to the ends of these two plates. Students then complete a critical juncture assessment, and they do a differentiated lesson to review key concepts they have not yet mastered. This leads us to the progress build 2, which states that plates move on top of a soft solid layer of rock called the mantle. At plate boundaries where the plates are moving away from each other, rock rises from the mantle and hardens, adding new solid rock to the edges of the plates. At plate boundaries where plates are moving towards each other, one plate moves underneath the other and sinks into the mantle. Go ahead and pause the video now, take a look at the Chapter 2 Focus Task Assessment, complete the model on your own. Here is a Chapter 2 Focus Task exemplar. This is a possible proficient model. Students should label the trench at the convergent plate boundary. They should also label the mid-ocean ridge at the divergent plate boundary. Students may add volcanoes near both plate boundaries. All right, jumping right into Chapter 3. Students will be answering the question, how did the Mesosaurus fossils on the South American plate and the African plate get so far apart? Students begin Chapter 3 by watching a short video introducing them how GPS technology is used to study plate motion in real time. Students then gather evidence in the sim calculating the rate of plate motion over millions of years, and they compare this to current plate motion. Students come to the conclusion that Earth's plates travel at a rate too slow to be experienced by humans. They then read and annotate an article called A Continental Puzzle. While reading this article, that students learned that the Earth's outer layer is made up of slow-moving plates, and the evidence for this can be found in rock formations, similar fossils, identical landforms, as well as the edges of the continents and how they fit together like puzzle pieces. Students then use this evidence to reconstruct a supercontinent as it was 200 million years ago. They come to the conclusion that it takes a long time for Earth's plates to travel great distances. Students then will end their explanation of this puzzling phenomena by examining some new evidence, using the reasoning tool to make connections between this evidence and the claim about how the South American plate and the African plate moved, which leads us to then Progress Build 3, which states that plates travel at a rate too slow to be experienced by humans, but can travel great distances over time. Go ahead and pause the video now to take a look at the Chapter 3 Focus Task Assessment to complete it on your own. Here is an exemplar for the Chapter 3 Focus Task. Go ahead and pause the video now and read through the exemplar. All right, so going right into Chapter 4. So Chapter 4 is where students apply what they have learned to a new question, which is what best explains the pattern of volcanic activity and earthquakes on the Jalisco Block. Students are introduced to this new question through a message. They learn about this area in Mexico called the Jalisco Block and how it is experiencing a lot of volcanic and earthquake activity, and how it is also very close to many different types of plates and plate boundaries. Students must come to a conclusion whether the Jalisco Block is experiencing a convergent movement or if it is experiencing a divergent movement. They learned that scientists have GPS data, but it is inconclusive as to how the Jalisco block is moving. Because of this, many scientists have gathered data and other information about this area to try to figure out what is happening there. Students then use several pieces of evidence to help them build their arguments. They then participate in a science seminar where they discuss the evidence to determine which claim best explains the pattern of geologic activity on the Jalisco block. They end the unit with a chapter 4 focus task, which is where they are writing a scientific argument to Dr. Moraga and his colleagues to explain what is happening at the Jalisco block. Go ahead and take a few seconds, pause the video to read through this assessment. Students at the end can either use claim 1 or claim 2 as long as they have solid evidence and even solid reasoning to explain how their evidence connects to their claim. Go ahead and pause the video, take a few minutes to read through both of these answers. Students then end the unit with the end of unit assessment. Let's go ahead and take a look at some of the questions that students might have to answer. Here's an example of a Progress Build 1 question. Go ahead and see if you can answer this on your own. Pause the video. If you answered B, you are absolutely correct. Remember, underneath both soil and the ocean, Earth's outer layer is made up of hard, solid rock, as stated in Progress Build 2. All right, let's see if you can answer a Progress Build 2 question correctly. Go ahead and take a few minutes, pause the video, answer the question on your own before moving forward. If you chose answer D, you are absolutely correct. Remember, soft, solid rock from underneath the plates rose and hardened, adding solid rock to the edges of both plates when plates move away from each other, as stated in Progress Build 2. All right, let's see if you can answer a Progress Build 3 question. Go ahead and take a couple of minutes, read through the question, try to see if you can answer this on your own. If you chose answer A, you are absolutely correct. India and South Africa are parts of different plates. These plates slowly moved far apart as soft, solid rock from underneath got added to the edges of the plates over millions of years, as stated by Progress Build 3. Here's an example of a constructed response question that students will have to answer in the end of unit assessment. Go ahead and take a few seconds, read through this question, try to see if you can answer this on your own. All right, here is an example. Remember, in order for students to reach a level 3, they must demonstrate an understanding of levels 1 and 2 and explain that the plates travel at a rate too slow to be experienced by humans and that it takes a long time for plates to travel great distances. All right, well, thank you so much for going through this with me. You are all done. So shout out to you. Final steps for KIPP teachers: make sure you complete the next 7 things so that you are ready to go. Thank you so much.